Okay, now we're back, and I also wanted to point out that refraction makes objects appear to be in different places. Now this is going to be different than reflection. So if you recall, when we had a mirror like this, and then you had a object that was in front of the flat mirror, then the image was located over here somewhere. And so whatever this distance was from here to here, it was the same distance from here over to here. So that this was the object, and then this was the image. So that it was pretty easy to predict the location of the image when it was a flat mirror. Now this time, it's a little bit more difficult when we talk about refraction. So this one was reflection. Now we want to talk about refraction. And so in that picture there, you see a picture of a guy looking at a fish. And so he thinks that the fish is actually closer to the surface than what it really is. So you've got the fish is this, so this would be the object. So that's the actual location of the fish. Okay, here is the surface of the water. But because of refraction, we know that a light wave that's traveling in this direction is going to bend when it gets to the surface of the water, and it's going to shoot off in this direction. So I encourage you to do the thing with the car and to show how the wheels get stuck in the mud and how it changes direction. So this would be the mud down here, and then this would be the dry grass up here. So I do want you to verify in your head that it's going to shoot off in this direction. And so here's where the person is going to be located at. And so they're going to see the image of the fish. But we're accustomed to thinking that light travels in a straight line. So we think if we continue this as a straight line over here, we're going to think that the fish is actually located up there when in fact it's located down here. So this would be I, the image of the fish, and then this would be O, that would be where the fish really is. Now, this class could save your life. All right, so if you are stuck on a deserted desert isle and you need to kill a fish, remember that the location of the fish is actually going to be below what you see. So that when you look at the fish, you need to take your spear and you need to aim for below where you think the fish is if you really want to strike the fish. So if you're stuck on a desert isle and you keep missing the fish, it's not my fault. Okay, I'm trying to tell you where to aim the spear. But this is an example of physics. And we could, by using the law of refraction, we could even determine, how high up do we need to aim, or how far down below do we need to aim the spear in order to hit this thing. So we're not going to do it, but geometrically we can draw it, and then mathematically we could even compute exactly where you need to aim the spear. Okay, so we're going to take another break. When we come back, we have talked about flat reflection. We've talked about curved reflection. We've talked about flat refraction. And now we need to talk about curved refraction. So I'll see you in just a moment.